Next up, I'm gonna show you how to solve the ALEKS problem, highlighting the stereogenic carbons. So what ALEKS is asking us to do is it's going to show us a compound and it wants us kind of to highlight the stereogenic carbon, which pretty much means that the carbon has 4 different things attached to it. So with this question, as mentioned, we're looking for the carbon with 4 different things. And then as you like draw this out on paper, or you're still kind of learning about stereogenic carbons and chirality and whatnot, feel free to write an X over those carbons that are CH2, CH3, or double bonded. So let's look at this first molecule. I see that I have a CH3 right here. So I'll just go ahead and write an X over it. CH3 right here, write an X over it. And then I'll kind of look at this carbon here. I'll circle it just for the image sake. And because I have a CH3 right here and another CH3 right here, I'll go ahead and eliminate that. So I know that I won't highlight that carbon. Next up, I'll move to this carbon right here. So because I already see that it has the fluorine and the chlorine attached, which is going to be kind of a tip for this question, is look for the carbon that has fluorine, chlorine, bromine, or something like that attached. But I'll circle this carbon, and I see that I have a fluorine right here, a CH3, which is right here on this side. I'll put a number 2 for that. And I see to the right of it, I have this compound, this carbon with 2 CH3s. So I'll circle all of this, and this will be number 3, right? And then on the other side, I have a CH2, 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 CH3. I'll circle all of these right here because this counts as its own element too, because CH2, 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 CH3, I can label this as number 4. So I see now that on this carbon right here, I have 1, 2, 3, 4. So I'll go ahead and erase it. And so with this question, I will highlight just this carbon right here. And because this, again, CH2, 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 CH3, sticking to the rules, those won't be the carbons you select. Now let's go down to this one right here. Again, following that same rule, no CH3 right here cannot be it. CH2 can't be it. I have this carbon. Again, I'm looking for the ones that are attached to Cl, bromine, fluorine, or whatnot. So I'll circle this one, and I'll see what I have attached to it. I see on this side, and I'll circle it, I have a CH2 and a CH3 right there. So that's 1. And then I see on the other side right here, I have the same thing, which is going to be a CH2 and a CH3. So because I have 2 on the carbon out of the same thing, so overall the CH2 here and the CH3 and the CH2 and CH3, I'm going to know to click, or I'm going to know right here to click there are none. So this one won't count. Even though I had a chlorine right here, which would be 1, because I had 2 and 3 right here, which are the same, it won't count. And then also number 4 for this one will be a hydrogen. It's at this point, you should already kind of know your skeletal structures and whatnot. The hydrogen won't be visible in the skeletal structure, but that'll be number 4. But because 2 and 3 are the same, this one won't count. And then at the end, I showed an example to the right of when you have a double bond. And so if you have this case right here where it's a double bond on one side, so you have a CH or whatever, or you pretty much have a CH right here. And on this side right here, you have a CH2. So because these two differ, and you see like the double bond on this, these two differ, this will go ahead and, you'll highlight this molecule because that'll count as a stereogenic center. So again, fairly simple. Just, utilize your rules of looking at the carbon that has something attached and then just circling what's on each side of it to see what really matches up. But again, if this video helped you or your classmates, feel free to like, share, and subscribe to the channel. Thank you.